To factor a polynomial, we need to break down that polynomial into smaller polynomials that, when multiplied together, equal the original polynomial. If we look at example 1, we have a quadratic polynomial that has 1, 2, 3 terms. So it's a quadratic trinomial. To factor this quadratic trinomial, we're going to set up two sets of parentheses, and we're going to undo the FOIL method. The first two terms in each parentheses have to multiply together to give me x squared, and my last two have to multiply together to give me negative 12, so that when I FOIL, my middle term will be negative x. Well, the two multiples of 12 that give me 1 are 4 and 3, and I need the 4 to be negative and the 3 positive. Example 2 is also a quadratic trinomial. To factor the quadratic trinomial, set up two sets of parentheses. First two terms in each parenthesis have to multiply together to give me x squared. The last two have to multiply together to give me 25. And when I FOIL, my middle term has to be 10x. If you notice, x plus 5 times x plus 5 can be rewritten as x plus 5 squared. In example number 3, we have a quadratic binomial. In this case, we're missing our x term, and we have a subtraction sign between our two terms. This problem is known as the difference of two squares. When we have the difference of two squares, we can still factor this quadratic. Our first two terms, x and x, and our last two terms have to multiply together to give me 9. Well, the reason I can do this factoring is because 9 is a perfect square. And if I make one 3 positive and the other 3 negative, when I FOIL this out, my middle term will disappear, and my last term will be negative 9. In this example, I have a quadratic binomial. Before I factor anything, I need to look to see if I have a monomial, a single term, that I can factor out. Between 6x squared and 3x, there's a 3 that's common to both terms, and there's an x that's common to both terms. So I'm going to factor out of this binomial 3x. So if I factor out a 3x out of 6x squared, I'm left with 2x. And if I factor a 3x out of 3x, I'm actually left with 1. I need to have this 1 here so that if I distributed back, I would get a 3x here. If I don't have the 1 there, I don't have anything to distribute to get this 3x. Notice that these two expressions, 3x times quantity 2x plus 1 and 6x squared plus 3x, are equivalent. The whole idea of factoring is that our original polynomial and its factored form are equivalent. And we can always check that answer by FOILing or distributing. In example 5, we don't have a quadratic anymore. Instead, we have a cubic polynomial. And we only have two terms in this cubic polynomial. So this is going to be the sum, because we're adding, of two cubes. In order to factor a problem that is the sum of two cubes, we need to follow a pattern. That pattern is going to be this. Something cubed plus something cubed can be factored. To factor it, I'm going to factor it into a binomial, a plus b. times a trinomial, a squared minus ab plus b squared. So if I look at this problem, I need to rewrite this problem as something cubed plus something cubed. Well, x cubed is quantity x cubed. Now I need to look at 27. Well, to figure out 27, 27 is a perfect cube, and it's 3 cubed. 3 times 3 times 3 is 27. So after I've rewritten my polynomial as something cubed plus something cubed, whatever is inside my parenthesis becomes my a and my b. So I plug x in for a into my formula and 3 in for b. So I'm going to end up with x plus 3 x squared minus a times b, x times 3, plus b squared. Now I'm going to do that math. X plus 3 times x squared minus 3x plus 9. So I can factor x cubed plus 27 using the sum of two cubes formula. Looking at 26, or excuse me, looking at 6, there's a monomial that's common between both 16 and 250 and x to the 5th and x squared. So step one before I do anything is I want to factor out the biggest common factor of these two terms. Well, that biggest common factor is going to be 2x squared. Now if I factor a 2x squared out of 16x to the 5th, I'm left with 8x cubed minus 125. I can't factor this part anymore, but I can factor this part right here. To factor 8x cubed minus 125, I'm going to have to use a formula very similar to the sum of two cubes, but this time I want to use the difference of two cubes. The difference of two cubes will look like this. Something cubed minus something cubed equals the binomial a minus b times the trinomial a squared plus ab plus b squared. Notice these two formulas look very similar. The difference is, in the sum of two cubes, I have one minus sign here, and in the difference of two cubes, I have one minus sign here. Other than that, the formula is the same. So to factor this part, I'm going to keep the 2x squared out in front of the parentheses, and I'm going to rewrite 8x cubed as 2 cubed x cubed. 8 is 2 cubed. 2 times 2 times 2 is 8. 8 is a perfect cube. And 125 is also a cube. It's 5 cubed. So now I'm to the point where I can rewrite this part as something cubed. So I have 2x squared out in front, two cubed x cubed. I kind of have the same power, so I can factor out that same power and rewrite this as quantity 2x cubed. If you notice, this part is equivalent to this, and this is equivalent to this. If I distributed this power back into the parentheses, I would have 2 cubed, which is 8, times x cubed. So this is equivalent to this. And 5 cubed I'm going to rewrite as quantity 5 cubed. So this part right here is my A, and this part right here is my B. Again, I'm going to keep my 2x squared out front. I've already factored that out way at the beginning. And now I'm going to use this formula. A minus B, 2x minus 5. A squared is going to be 2x squared. Notice that I put 2x in parentheses, plus 2x times 5 plus b squared. Now I need to simplify this part. I'm going to write my answer over here so I have a little more room. 2x squared times 2x minus 5 times 2x squared is going to be 2 squared, 4, times x squared. The most common mistake students make is they forget to distribute this squared to the 2 and to the x. I'm squaring this entire A, so I have 2x times 2x, which is 4x squared. If you wrote down just 2x squared, that's not quite right. It has to be 4x squared. Plus 10x plus 25. If I distributed this polynomial into this polynomial and multiplied, I'd end up with x cubed plus 25. These two things are equivalent. If I distributed all of these polynomials and multiplied everything together and collected all my like terms, I would end up with this polynomial. These two expressions are equivalent. If I look at number 7, I have a cubic polynomial, but this time I have 4 terms. Well, I can't factor using the sum of 2 cubes if I have 4 terms. So there's got to be another method to factor this problem. And that other method is called factoring by grouping. To factor by grouping, I'm going to first group my first 2 terms together and then my second 2 terms together. If I look at my first 2 terms, I have an x squared common between these 2 terms. So I can factor out of just the first 2 terms x squared. And out of my second 2 terms, I have a 4 that can be factored out. So I'm going to factor out a positive 4. Notice that this expression is equivalent to this expression. If I distributed this x squared into the parentheses, I would have 3x cubed minus x squared plus 12x minus 4. I haven't changed my problem any. I've just factored out a term from my first 2 terms and a term from my second 2 terms. Now I'm going to look at this as 2 more groups. I have this group and I have this group. Well, each one of these groups has a 3x minus 1 common between them. So I'm going to factor out a 3x minus 1. And if I factor a 3x minus 1 out of this group, I'm left with x squared. And if I factor a 3x minus 1 out of this group, I'm left with 4. If you think about it, if I take this term and I distribute this whole term to x squared, I get this. And if I take this whole term and I factor it to this 4, I get this. So these two are equivalent. At this point, I'm done. 3x minus 1 can't be factored, and x squared plus 4 can't be factored. I do have a way to factor the difference of two cubes, or two squares, but I have a plus here. This can't be factored anymore. Looking at number 8, we have a cube, and we have 4 terms. So we're going to factor by grouping. We're going to group our first 2 terms together and our second 2 terms together. Out of the first 2 terms, we're going to factor out an x squared. And out of our second 2, I'm going to actually factor out a negative 1. Now if I factor a negative 1 out of negative x squared, I'm left with positive x. And if I factor a negative 1 out of positive 2, I'm left with negative 2. This looks a little weird, but if I distribute, negative 1 times x is negative x, and negative 1 times negative 2 is positive 2. So these two expressions are equivalent to each other. I have to factor out a negative 1 here so that when I factor by grouping a second time, I have a common term. So I'm going to factor out x minus 2. If I factor an x minus 2 out, I'm left with x squared minus 1. Now this problem, I can keep going. I have to keep factoring where I can keep factoring. In this case, I have an x squared minus 1. X squared minus 1 can be factored. It's the difference of 2 squares. If I FOILed out these two factors, I'd end up with x squared minus 1, so I've kept equivalence. The difference between these two, I can factor a quadratic when there's a minus sign here. I can't factor a quadratic when there's a plus sign.